All right, guys, welcome, welcome. Pretty, and back with me. Allison, please. Sales. Title. Okay. 7-1, we're going to talk about roots today. We're going to talk about roots. Okay? So, here we go. So, rational roots. We're going to go from radicals. What is this written as a power? Does it mean, well, it's 2, damn it. That's not how we'll make it that way. 14. Okay? Square root of 14. How do I make that a power? Have we learned that ever? You should have, but you might forgot. What this is understand, guys, what's his power on 14 even though it's not there? 1, right? There's a 1 there. What's this called? What kind of a radical? Square root. What's here even though it's not there? A 2. That's saying we look for groups of 2, correct? 2 is a cube root. We look for groups of 3. Fifth root, groups of 5, and so on, right? We can write this as a rational exponent, which is 14 to the 1/2. A square root is the same thing as the 1/2 power. Okay, so in general, I have a to the m underneath the nth root. What would you guys say that would be? A to the m divided by n. That's pretty big today. I'm a loser, baby. I'm not going to say that part because I like to stay alive. Where is everybody today? Who's it there? You're such a good friend.
No, wait.
Oh.
Didn't you? Oh yeah, you're right. I have no idea. That's it.
Did you assume his gender?
Yeah.
We don't do that anymore. Okay. So, do everybody, I'm going to ask you guys right now, how many of you guys know your perfect squares up to 20? So here we go. Here they are. 1 squared is 1, 4, 9, 16, 25, 36, 49. Most of you guys all know these ones so far, right? We usually know up to 12. Would you guys agree? 64, 81, 100, 121, and 144. Those are the ones you usually know right off the top of your head. Okay, but after that, they might get a little bit in. You guys know what 13 squared is? That is 169. 14 squared, 196. 15 squared, 225. After 15, 16, huh? 16 squared is 256. Okay. 17 squared is 289. 18 squared, I believe, is 324. I struggle with that one a lot, but I believe it is. Can somebody check that for me really quickly? Maybe with the machine out. Am I right? Yay! That was 18 squared, right? 18. How about 19 squared? This up to what? I got it, didn't I? And last but not least, 20 squared, that's an easy one. That's 400. Okay. If you guys know those, and if you don't, I would highly suggest you do, especially because it makes it nice. Those are perfect square roots, or perfect squares, right? So if I take the square root of those numbers, it comes up to be a perfect number. You guys agree with me? Okay. How about our cube? Not that I'm going to go all the way to 20 cubed. Okay. Anybody know that, though? Here we go. What's 1 cube? 1, 2 cube. 8, 3 cube. 27. 4 cube. 64, 5 cubed. 125. That's usually as far as I go. I think 6 cubed is 3. What is? I don't know that one. See, 390, 196. Not 3 cubed. 6 cubed. 316. Like that. Okay, so those are up to 6. I don't know those very well after that. Okay, on my fourths, 1, 16. 3 is 81. 4 is 256. And then 5 is 625. That's about as far as I know on my fourths. On my fives, I really care about these two really. But there is a 243 if you want to know that one. This one's 1024 if you want to know that one. I don't know what the next one is. I think it's 3125. 5 to the 5th. Am I right on that one? Anybody check me? Yeah? Okay. Just knowing these numbers, though, can help us quickly do what we're also doing today. Okay? For example, what if I said, what is 64 raised to the 2/3 power? 64 raised to the 2/3 power. Well, I know 60 without using a machine. Not saying to use, but I just trying to do it without a machine because I might take it away a little bit. You don't know your timesy tables? No. So you've let your brain go away because technology is available. Okay, notice guys, a way to do this is the same thing as this. What does that 3 represent? It's the cube root, huh? Remember, the 3 represents a cube root. What is a perfect cube root of 64? This is the same thing as 4 squared. Because the cube root of 64 is 4. That was on one of our lists. If you want to look at it really quick. Our cube roots, 1, 8, 27, 64, right? Yeah, that's a perfect cube root of 4. I mean, it's 4 cubed. Right, Mr. Sriracha? You tired today? Wet Willie, I can always help you out.
Oh, no.
Have you ever given a Wet Willie? So anyway, and then I just have the squared here, which is 4 squared. Okay? Somebody help me out with 64 times itself. Is it 4096? I did that earlier. I think that's what it was. 64 squared. So, or I could do this, guys. The cube root of 64 squared. Hold on. Woo. Ah! Well, I guess I could write it just like this. Isn't 64 squared 64 times 64? You guys agree with me there? Now, when we look for a cube root, what are we looking for? Roots of 3. What's in 64? 8 and 8, right? Okay. By the way, what's 4 squared? 16 is what our answer is going to be. Okay. Here we go. So 8 and 8, what's in 64? 8 and 8. Look right there, guys. I'm going to break them down because there's a group of 3. What's in 8? 2 and 4. What's in 4? Group of 3. Right? What's 2 times 8? Now, could I do it just by hand if I wanted to, just bring it out, right? I could, but noticing, wasn't it quicker to say this is a cube root? Is 64 a perfect cube root? It is. It is 4, so this is 4 squared, which is 16. So that's kind of why I showed you that little list, just so you guys can get familiar with those perfect numbers, right? Well, all the way up to the set. Okay? Everybody good with me on that? Any questions there? Should I give you one for you to try? Here, guys, try share. Grammar. 81 to the 3/4. Do I have any juniors in this class? I can't remember. This should be. Oh, yes. I'll go back that one. Where'd you move from, Declan? What part? Ah, northern fella. Well, that's more central, but that would be considered in the northern. I think I prefer Northern California than Southern. I like it because it's cooler. The water's cooler in California and Southern too. Not the same. Not the same. Is 81 a perfect fourth root or something raised to the fourth? What is it, Tommy? 3. So this is equivalent to who? 3 to the third, which is what? 27. Okay, let me ask you this question. Will I get the same answer? Do those mean the same thing? What does the top one say? Okay, is it saying -9 raised to the 5/2 power, or is that the bottom one? The bottom one is saying -9 raised to the 5/2 power. This is saying 9 raised to the 5/2 power times by -1. So which one of those can I do, top or bottom? Because remember, this is a half. Can halves or even powers be negative without getting into imaginary solutions? No, huh? Does that make sense to everybody? Unless I want to get into imaginary solutions, and that right now I really haven't taught you guys that, right? Even though we've all learned it by this time. Okay, I don't want to get into it. So I could do this problem, and this guy is not possible. Is it possible to do, what if that was the 5/3 power, even though that's 9 is not a perfect cube root, could I do it -9 raised to the 5/3? Yes, can something cubed be negative? -2 times -2 times -2, what do we get? -8, don't we? So can anything that is an odd power be negative? Does that make sense what I'm asking? Can an even power be negative? Because anytime I have even powers, they group up as 2s and they should be positive. So I come out, right? The answer is, does that make sense what I'm saying by that? So this guy's not possible, where this guy is saying, okay, I have my negative here. This is the same thing as the square root of 9, which is 3 to the 5th. 3 times 3 is 9, 27, 81, 243. Is everybody there with me? So this would be -243. Okay, whereas this one's not possible. Do you understand how big, when we go ahead and put parentheses around something, it means a whole different ballgame, right? How many of you guys have ever put in your calculator this? And it gave you this, and then you got it wrong on your test. Did it do exactly what it told you to do? It did the squaring first and then times by negative. The order of operations is I do the exponents and then multiply, right? But this is what most of you guys are trying to do, and you forget the parentheses. It should be 16. Does that make sense? Okay. Is everybody there with me on that? You see what I'm going for? Okay. All right, let's see where else we're at. Some nose, hippy hoppy, cuda. Oh. Oh. Oh, I forgot to talk about that in my last class. Uh-oh. Uh-oh, stereos. Okay, so really quickly, I'm going to ask you guys to do this, and I'm going to ask you guys to do this. Oops. Wish I really had a back button. Okay. we're going to talk about this. Once again, this is a square root. This is a fourth root, meaning we're looking for groups of 2. We're looking for groups of 4, correct? Okay, on here, how many groups of 2 are in 2? 1. Isn't there a group of 2 with an x squared? Does everybody agree with that? So that's just x. Notice, though, that's 2 divided by 2. That's how I got that. How many times can 4 go into 4? So does it look like they're the same answer, even though they're different things? Okay, they are, but they're not. And actually, this one is. I'll show you. Actually, they're the same answer. So what happens here, ladies and gentlemen, is this is squared to get rid of a square root. Do we know what the value of x is? Any of you guys know? Because isn't that what a variable is? Is it's playing, it's like playing pretend that it's a number right now. Okay? And we don't know that number. So what if that number was negative 3? Negative 3 squared is 9. What's the square root of 9? 3, but we said it was negative 3. How does that work? You know what I'm saying by that? You get where I'm going? So what I'm saying by that, guys, if it ever comes out of an even power, and it comes out, even root, odd power, even root, odd power. Get in my cult and say even root, odd power. You don't have to say it, but it's like a mini cult. You're just going to say even root, odd power, and we're going to go feed you guys to the math gods, okay? Whatever, but even root, odd power. If it ever comes out of an even root and it comes out odd power, you need to put absolute value around it. Did this guy come out even root? Come from an even root? Yes. Did he come out odd power? Yes. So he needs it. How about this guy? How many times can 4 go into x to the 8? Or how many times can 4 go into 8? Twice. Even root. Did he come out odd power? So do we worry about it? Why? Well, something that comes out even power, when I do it, let's say x was negative 3, if I square that, wouldn't it always come out to be positive anyway? You get what I'm saying by that? So that's something to write in your note. If it ever comes from an even root and it simplifies out as an odd power, we do absolute value around it. Okay? Now, do we care about those numbers? No. With variables, yeah. Okay, so if I said, what's the square root of 49, that's just 7. It's not the absolute value of 7. Does that make sense for everybody? Okay. Even root, odd power. Getting that little cold. Okay. Awesome. You guys are pick A. Some of you. Maybe not all. I don't know. We'll go there. Ooh, I like this one. I like this one a lot. Oh, yep. Yeah, I like that one. We'll go there. Well, let's start to here. Okay. What? Okay. You get it up there so you can sing the national anthem by your lonesome? Fine. You're a big girl, though. I heard you. Never mind. That's not bad. I was going to say, I heard you wear your big girl panties. So that doesn't sound weird that people would be talking about it. Anyway. You get what I'm saying. No, sure. I think you'd rock it. How about you, Carter Cowan? Are you going to go try? You guys are all singers again. You don't want to try. Joseph! All the girls will fancy over that lovely flow of the blonde hair. Okay, here we go. We're going to write this as a rational exponent. Right now it's a radical, isn't it? Okay, but we are going to do a rational exponent. Rational exponent. Did you go to a Rolling Stones concert? Well, I just saw your shirt. Okay. Because they're getting old. What's the power on E even though it's not there? 1. So what you want to do, guys, is kind of think about this as each individual. Does everybody understand how that's an individual of each style, basically? Some people, what do you guys think some people do? Did any of you guys think this was 8x cubed, meaning the whole thing was cubed? A lot of people think that. Because that he's cubed as well. But once again, that's what it would look like if it was the case. Is everybody there with me? Okay, if there was parentheses, then both the 8 and the x are being cubed. But without them, who would be the cube? Just the x, right? Does that make sense to everybody? Are you disturbing my class, young lady, that's here on my time? Just be good about that, okay? What is this raised as? What would you say this as? 8 to the 1/4. X to the 3/4. You're doing all this stuff. Y to the 1/4. Does everybody see how I went through that? Each of them had that. How much do you weigh? Let me guess. I'm going to say 110. Okay? That's like my thigh and my knee is below. That's the difference. If I got rid of just this, that's you. I'm just carrying you around right around the belly. Now do you understand? Yeah, I got insulation for days. Okay. Sometimes, guys, I get messed the heck up, right? Oh. I'm a freak. Yeah. Super freaky. Oh. Who's the tapper? Yes. I was about going on a witch hunt. Because that stuff just. You got a bloody nose? It's because it's so dang hot in here. We got elevation. Those two combined from California, man, that's a whole different ballgame. My friend, he moved from Texas. And he came here, he's like, don't you guys have any darn water in your air? And I'm like, dude, we're a desert. Because he moved from Houston, which has lots of water and humid, right? His skin was cracking like nastiness because he would steal girls' smelly lotion all the time. Because skin lotion. I'm like, lotion? What is that? Okay, what would this be? M raised to what power? 1/3. N raised to what power? 2/3. I think after this we got this idea, don't we? And then 3 raised to what power? 1/3. Hey, hippy hoppy, hippy hoppy. Okay, notice, ladies and gentlemen, a to the m over n. Remember, I did show you that was nth root of a to the m. But you could also write it like this. A to the m raised to the 1n. You might want to know that as well. Once again, guys, how do we do power to a power? We multiply, don't we? So if I had m times 1 over n, wouldn't that be m over n? If I just plug them right across fractions. I know fractions are your favorites, but you guys are sucking up knowing you're thy neighbor. You know? Do you know, Tasia? Huh? You don't know. Who is it? Who can't see her? You're here for one whole test day. Tommy, my man Tommy's back there. All right, that's good. That's good. That's good. I like you all. Going on 7-2. If you have your Bookola, your El Libro, turn to page 542, because I don't want to have to go over these, because I'm sure I know them. Well, maybe not. I'll go over them because you're not supposed to know anything. Okay, so, ladies and isn't that what it is? Don't mock me. If I'm right, if I'm wrong, mock me. El Libro. What did I say the first time? La Libro, that's messed up. I did. Okay. So, if they are like bases, what do we do to their exponents? We add them. For example, x cubed times x to the second. Whitney, wait. X to the fifth. Are you going on a drink run? I don't need more food. I got food. I just was hoping. Huh? Why? Midnight. Two kids came and asked me what they like. Should I be an A1? No. Because A1.
Oh, in the honor.
A1, A2, A3, A4.
All honors, you're right. Oh, we told them any other honor but A1.
And A2. They're okay.
Yeah.
They're my biggest.
Well, then,
it's okay. I thought if you were going on your swig run, sometimes you do.
yeah, sometimes I do.
Nope, you're good. Awesome sauce. Thank you. Okay, we have when we're once again multiplying, we add. What happens when we divide? We subtract, right? So what if I had this one, though? This is actually a really good question. What if I had a to the second over a to the sixth? What would I have? Good. A to the negative fourth, which is, what did you say, Declan? 1 over a to the fourth. Are those both the same result? Yes. If you ever have a negative exponent, that is not simplified, though. We never want to see a negative exponent. That means it's not simplified. Okay, so what I say is another saying part of my cult is jump the line, change your sign. So he was upstairs, right? Now he jumped downstairs. He changed his sign of his exponent. Even root, odd, tower, jump the line, change the sign. Yeah, I have tons of them. I can make a rap video out of that. Yeah, with that monk music that is, you know. Yeah, that stuff. Yeah. Okay, we just did the quotient rule. We need to do the power rule, which we kind of went over a little bit. If I have a to the m raised to the n, what do we have? mn, right? Think about that. If I had x squared to the fifth, isn't that written out x squared times x squared times x squared times x squared times x squared? And then I'd add all those together. What's repeated addition? Multiplication, right? I have a question for you. No, it was all right. I just wanted to make sure. Okay. So if I had x squared to the fifth, that would be x to the... Hey, that's not where... You would not sleep on your belly. I will unsign. Yes, sometimes if you get an appropriate course. But it's hard. It's hard. You got to get a shelf. You got to... Do we all do that stuff? Do I need to do that stuff? Okay, good. Because I'm not going to go more into it, but I am going to talk a little bit about this. So if I have 27 to the 1/3 and times by 27 to the 5/6. Is that one I want to do? Oh, it's 1/2. Sorry. I'm in 7-2, by the way, now. Right in there. That was not my finger at all. It was this. Okay. What do I do when they're like bases and they're multiplying, my man Tristan? Jaden? Jaden. Tristan. Yeah, I was right. So why'd you give me a weird look? Go ahead. I add them, but we have to add fractions. You guys are like, son, all right. Allison, did you say that? By the way, congrats on Student of the Week. Yeah, I saw that on the Facebook page. What was it for? Good job, then. Well, if you were, thank you. And if you don't know, that means that that's nice because you should know whether you should always be a good friend at all times, right? That's inspiration. Okay, so really quickly, ladies and gentlemen, what's 1/2 if I can get it in the same common denominator? This is the same thing as 3/6. Does everybody agree with me on that? So I'm going to add those two together, which is 27 to the 8/6, which is 4/3, right? Can I simplify that though? Is 27 a perfect cube root? It is. So this is 27 to the cube root. Does everybody understand why it's the cube root? Okay, so that's 3 to the 4th equals 3 times 3 is 9, and 3 again is 27 with another 3 is 81. Okay? You guys gotta have more fun. I understand math isn't everybody's favorite stuff, but I can be annoying enough just for you to make it worthwhile coming. All right. Yes. What's the cube root of 27? Oh, wait. That's right. You mocking me openly?
No, my fingers are really hot.
Ooh. I won't today. It'll be nice. Close though. All right, let's do another. Oh yeah. Oh yeah. Huh? Hey, it's my friend. Well, he wasn't my friend. He was a student of mine, which he really isn't a friend. He's a, yes, you get what I'm saying. He's never hung out with me. We'll put it that way. But he went to Utah State and they have what they call the Howl, which is a pretty big. They charge $50 or some kind of outrageous amount of money for this Halloween party. He's a big guy like me. And he took off his shirt, just painted himself all red, and put a smile. I thought it was pretty clever. I thought it was pretty cool. He said it saved his body for a while. Yeah, he gave it once today, did you? Yeah. First off, can I do anything on the inside yet? Because they're not like, right? If they were the same, could I? But right now, I just got to bring him in, don't I? Okay, so what's 3/2 times 2/3? 1. So this is just 8. What's 5/4 times 2/3? Well, let's bring that out. That's 5 times 2, which is 10. 4 times 3, which is 12. So we're at 10/12. Is that how I'd leave my answer? I'd have to go 5/6, right? Okay. Do we all do that, you think? A lot of today's not hard. It's just you've got to remember the rules, right? Got to remember the rules. Okay, so I'm going to do this next one for you. Well, not for you. Okay, what's our problem here? If I had this to be both underneath the square root and a square root, can I simplify underneath both of the square root? I can, but this is not a square root. That's a square root. This is a cube root. So can I just get rid of the z? No. So the first thing I would do is get it as a power. Okay? What is z underneath the square root as a power? 1/2, that first on the top. Now the bottom would be what? 1/3. Correct? Yes, no? Now, because now they're just like bases with powers, can I move on? I can. Because now I'm just like bases, I'm good to go, right? So what do I do once again when I go ahead and divide? I subtract their powers, correct? Can I just go 1/2 minus 1/3? No, right out of one. No. So I need a common denominator. What does 3 and a 2 meet up at? So this is 3, 6. This is 2, 6. So what do I end up with being? D to the 1/6. Because we are subtracting. Everybody see how we did that? Might want to be faster on that. Okay? Okay. I've been told I've been going a little too fast, so I don't want to. Oh, this is a good one. Okay, ladies and gentlemen, I prefer to start with order of operations. Yes, it is. You are so good. No? Thank you. Okay, are you ready to go play some flag mud football for the FUFA? This is Elijah. That's where Elijah sits. He's a very nice man because he's on the FUFA as well. You know what FUFA is? All right. The FUFA? FFA? FUFA. Are you part of the FUFA? Asia? Are you going to play some flag mud football? Arnell? No. He doesn't even look like a FUFA kid. It's all right. I could have been a FUFA kid. I put my arm up into a lovely valley. It's really not a river with the other big one. I don't know if you guys like right? But I felt up in there. It was an adventure. Because we had to rotate it through the eat it. I have cut some testicles off with some bullets that live between spears. You guys know when you look out into a field and you guys look at all those cows, and I always ask people, I'm like, how do you know they're all female? Touche, huh? Because most people don't know when you see a herd of cattle, that's what you should say, they all say cows. And I'm like, well, I don't know they're all females. Because a cow is a female bovine that has had a baby. Or an older. Usually they've had babies. Have you ever said, look at you, you heifer? Have you ever heard of heifer? A heifer is a female bovine that is yet to have a baby. Usually a younger one. Did you know that? So I'm teaching you here. I can be part of the FFA. Tell you what. What? You heifer? Yeah. Yeah, I bet that is. Have you ever watched, what's it called, Duck Dynasty? I remember the guy that used to drink all the tea. Sai, I think his name was. He would always call people, you stupid heifer, or something like There's actually t-shirts made.
No.
Oh, we're not done. So, oh, it's all because of the fufa. Way to go, fufas. Okay. So can we simplify what's inside? Is there any other numbers besides 9? No. So I'm going to leave 9 alone. Okay. Is there any x's on top or bottom? Then I need to work on that because I only want one singular x. Does that make sense? So let's look at the x's. I got x to the 5, 6 here, but I got x just on the bottom. What's the power on x if he's just by himself? 1, or we could say he is 6 over 6. Do you guys agree with that? Why would I want to do such? Because then I'm already in the common denominator, right? So 5, 6 minus 6, 6 is negative 1, 6. Or could we just understand who has more, top or bottom? The bottom does. 6, 6 is bigger than 5, 6. So where should my answer be? On the bottom. Do you guys agree with that? So this would be x to the 1, 6. But notice when I subtract, I'd get x to the negative 1, 6. But once again, part of my quote, what do we say? Jump the line! Change our sign. That's why he's down there, right? Okay, is everybody with me so far? Okay, how about y's? We got to play with them? Negative 2/3 minus 4/3. Yeah. Negative 2/3 minus 4/3. Oh, wait. Which is negative 6/3, which is negative 2, which would put us where? Downstairs, right? Because the answer after you subtract is always on top. And think about this. There's 4/3 already down here. Couldn't I just already move him down at the beginning? Right? And then I have 4/3 and a 2/3. What does that have to be? 6/3. Does everybody understand why I'd be down here? Well, what's on top? I don't have anything left. There's always a 1, though, isn't there? Some people put a 0 and stuff, but there's always a 1. All right. We're getting there. Now I have this negative 1/2. Okay? I'm going to show you a trick. But notice, guys, if I bring him in, what's 1 raised to any power? Any power. It's always 1, isn't it? So really, he's going to stay 1. He would be 9 to the negative 1/2, 9 to the x to the negative 12, and y to the negative 1. They'll all come out be negative, won't they? So where do they all go? They'll jump up top because they're jumping the line. They change their sign, right? I like you. Become part of my group. I will not ask you to drink Kool-Aid. Anybody get that joke? You okay with that? The guy that asked me to drink blue Kool-Aid? I will not ask you that. Water is all I have. Free. Okay, so here's another thing. If you ever have a negative exponent in general, all you have to do is flip the fraction inside. And it'll do so for you. So this would be 9x to the 1/6 y squared raised to the 1/2. Just want to bring one more time. If you ever have a negative exponent, you just flip your fraction. So for example, if I have 4/3 raised to the negative 3, what is that equivalent to? 3/4 raised to the 3rd power. Does everybody get that rule? Yes. Okay, so negative 6/3. Remember, anytime I subtract, where is that going to put us at, Brittany? Oh, yeah, Rolly's still down. Anytime you subtract, it always puts it on top. So if I have y to the negative 6/3, which is y to the negative 2, where is that going to go? Yeah, then y squared. Make sure it makes sense. These are my stars. All right. The Mustang?
No, that was my also not that.
Called Frontier?
No, on that.
I always told Principal Twitchell, not Principal Twitchell, Openshaw, you guys don't know him though. Has Twitchell always been here with you guys? Nobody else has been here? Anyway, I told Mr. Openshaw, I said, if Skyridge came out and they were orange, which they were orange, oh, it almost took me because they were orange. And they were buffaloes or some kind of a horse, I was gone. Just because of those things. But they were orange, and I had to dictate, do I really want to go? Because I really like the color orange. But they weren't buffalo. Buffalo, I'm telling you, anything comes up buffalo, done. Because I think buffalo are, I think horse is the most magnificent animal that's ever roamed this earth, and it's the most impactful animal to ever roam this earth. You could argue with cattle, but I'd say you're wrong. Huh? Think about what the world would be without a horse. Think about our agriculture, meaning just growing items. Right? How much do they help in just tilling the land back in the day and so forth? Now we have machinery, but, you know, it's quite impactful. Horse is magnificent. Onward. You shut your mouth. It's true, but yes. Does everybody understand why I got Y? I guess I could put 2 over 2 there so we can see that step. The next question you really want, isn't it? What is 9 to the half? What does that say? It's another name for the square root of 9, isn't it? Which is 3x to the 12th y. Yep, 1/12, sorry. It does. Oh crap, that's just horrible. We'll write it again. Is that better for you, Adam? All right, everybody want to know why Miss Flood is here? It's for these next examples, huh, Floretta? I love a good fairway. Great. Wow. What do those guys share? The base, right? X. X to what power do they share? Don't they both have a 6 in them? Because 8 has 6 in them, doesn't he? He has 2 left over. You guys agree? Remember factoring? Factoring what they have in common, you pull that out, right? So don't they have an x to the 6th in common? If you don't believe me, I can show you. X, 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 X. That's a really bad movie.
You can look at it, I go.
Okay. Notice how many they have in common.
9.
Oh, shut your mouth. Okay. So, shush. They have 6 here, and they have 6 here. All right. So I can pull the x to the 6 out. What's left over? I pulled everything out. What's left? Oh, everybody has a 1 there, right? If you lose the 1, don't I lose the place of what that would be? Right? Because if I just dropped it and said, oh, minus x squared, I lose my place, don't I? Okay? But what is factoring truly? This is where, I don't know if she showed you this, right? You've done this though before. When we pull something out, what did we technically do? We divided, didn't we? What's 6 divided by 6? 1, hence why I have a 1 here. What's 8 divided by 6? I mean, because if I'm doing this, well, hold on. Sorry, let me start over. How's that? If I did that, that'd be x to the 6 over x to the 6, which once again, when they're like bases, we subtract. Did we talk about what anything raised to the 0 power is? Would. 1. We all should know that somewhere, right? Hence why this is 1. This is when I factor it out. That's x to the 8 over x to the 6. What is this? What is that? 2. Hence why we have 2. So when we factor something out, what am I doing to the exponent? I'm subtracting the exponent they have in common from what they have. You guys agree with me on that? Make sense? Okay, so now I'm going to get into a rougher question. This was pretty easy, right? This is something you've seen before. Now, I'd like you guys to think about this. Does 9 and 4 have anything in common? No, they don't, do they? Does x to the 4/3 and x to the 1/3 have something in common? They do. They have x to the 1/3 in common. So I can factor that out. Okay? So just as I just showed you, we're going to pull him out. Now, the 9 had nothing to do with what we just pulled out, so we just leave him alone. But I just pulled a third out of 4/3. So what did I just do, though? When I factor something out, what did I just do? Dividing. So what do I do to the exponent? Subtract. 4/3 minus a third is 3/3. Hi, Caleb. 3/3, which is just 1. The 4 is still here. He's gone because I got him factored out, didn't I? Everybody agree with that? And then this guy's here. And really quickly, I can redistribute that through to be 4x plus 20. So our final end-all be-all answer is x. Why did I put a 6? I'm really sorry. You guys might be looking at me really weird. Does that make more sense now that it should be a third? I apologize. I'm left with 9x plus, oh, nope, erase that. 9x plus 4x is plus 20. I made something that looked that nasty into something a lot nicer. I'm here all day, really, seriously. 7:15 till 2:45. You ready for another one? Now we're going to do a harder one. That's it. Ah! This will be our last problem of the day. All right, who do they have in common? Plus 3, right? Raised to what power? Who's smaller? A half or negative a half? Negative a half, right? Would you guys rather have a half of a dollar or negative a half of a dollar? I'd rather have a half, so he's okay. Now once again, I factored him out. So basically right here, the 4 needs to stay because nothing to do with the 4, right? But I just pulled a negative half out of a half. What did I just do there? Remember, I'm subtracting, right? So I have 1/2 minus how much? Negative a half. So it adds, doesn't it? Think about that. Once again, remember when you factor out, just like we did here. Remember we factored out 6. We went 8 minus 6, right? You guys agree with me? Yes? You guys all see that. That's why she's here. She didn't see that earlier, correct, Ashton? Okay. So, I'm taking a half and subtracting a negative a half. Which makes a what? 1. Okay. Then him, I already took him out, didn't I? He's still here, though. Can I work within this? What does this become? Hey, I heard something about you. It was all right. I'm just curious how you did it. Really? No, really?
For what purpose? I'm trying to find the actual purpose of why they do it. You're talking about toys.
Yeah,
I'm here later.
yeah,
More parents can come in.
that's what needs to.
And I get a lot more that come in. I mean, there was a lot more the first 2 weeks.
Uh-huh.
I'm getting a lot of phone calls that I'm able to answer. And, hey, my guy's ABC's not done. Can you get on the computer tomorrow?
Gotcha. I'm just curious.
I also applied for 2 other jobs and do that. That option.
Where?
Space and stuff. I didn't get any interviews.
That's it, guys. Pretty simple, huh? Can't overthink it, can you? Okay. All right, here's your homework. Gotta find it though. There it is. So I don't know the page numbers exactly, but can you guys turn to the page of 7-1 and find it? You know what I mean? But there it is. Yeah, I just heard about that, and then I heard somebody.
Who I know.
Oh, I know the one that used the last.
Yeah. So, yeah. And then there's the no, I haven't been on about any of that conversation. Why? I got like secondhand information. Sure, it's not equal to well, nothing is. We could get Ron actually came back and said, I love the idea. Let's try it. If we're really
That's what I do, and I do it to every school.
Let's work it in across the board. You could work it in with multiple people too.
You could do multiple people, and it would be. But is it beneficial? That's the key thing you gotta ask.
Absolutely. Yeah, and there's the pros and cons. We're not gonna do a few issues, okay, I'm not here that day, so how do we work on it? If it's a later, we would take it. Other than that, they know, Monday morning, I usually have to my appointment, so if you can on Friday.
You come in earlier too?
So,
Just stay
I'm
here.
here till 5.
Okay.
And then they also changed our contract this year.
I heard that.
And with that change, we have to work these days.